The second question. A wagon of mass 2m moves on a straight horizontal rail with a speed v at t1. By the time t2, its speed increases to 4v. Which expression equals to the average power delivered to the wagon between t1 and t2? In this question, it is asking you the average power, so it's P. P, the power is obviously equal to P is equal to W over T. W is the work, T is the change of time. The change of time is basically just T2 minus T1, so we already knew that. And W, the work, is what we're going to figure out. What is work here? We will actually use a formula. Work is equal to the change of kinetic energy. This is a very important formula. Keep this in mind. So the change of kinetic energy is equal to K2, KE2 minus KE1, which is the kinetic energy it has at time t2 minus the kinetic energy it has at time t1. So let's just write it down. A formula for it is half times 2m, the mass of the wagon, times the velocity it has at time t2, which is 4v times 4v squared. It is 16v squared. Minus ke1 is half times 2m times velocity squared, v squared, because at t1 the speed is just v1, just simply just a v, right? So after we simplify it, it will be 15 mv squared. So this is a work. Let's plug this back to here. We already know delta t is equal to t2 minus t1. And the numerator is work, which is equal to 15 mv squared. So P is equal to 15 mv squared over t2 minus t1. So C is correct answer.